In this video, I will show you how to perform a dilation. A dilation is when you take a shape and you either make it bigger by a certain factor or you make it smaller by a certain factor. Now, a dilation is going to be a stretch if the scale factor is bigger than 1, and it's going to be a shrink if the scale factor is less than 1. So we want to shrink horizontally by a scale factor of 1/3. When they say horizontally, that means we are only going to talk about the x values. Right? So this is not a full dilation. This is just a horizontal shrink. So we're going to multiply the x value by the scale factor of 1/3. So I will have 1/3 times the x value. The y value will stay the same because we're not changing the shape vertically, only horizontally. So if I take these values and multiply all the x values by 1/3, so that means I need to take -3 and I need to multiply that by 1/3. Hopefully you can do that in your head. That if you multiply straight across, that's going to give you -3/3, which is -1. Okay, the y value stays the same. Now if I take this x value and I multiply it by 1/3, that's going to be 1/3 times 9. Okay, so that's just 9/3, and that is going to be 3. And of course, anything times 0 is 0. So if I do 1/3 times 0, I'm going to get 0. And the y value stays the same. So these will be the new vertices, or the images, after I do this horizontal shrink. So I'm just going to plot these points. So -1, 6 would be like right here. All right. 3, -3 would be right here. 0, -6 would be right here. And now I'm just going to connect those points. And that's it. Don't forget to label. So this will be A prime and B prime and C prime. So that is how you do a horizontal shrink. Okay, now looking at the next problem, all right, looking at problem number 2, this time we are given the rule and we're being asked for the other stuff. So I notice that we are only affecting the y values. So this is going to be something vertical. Maybe I should put it next. Now, because this is bigger than 1, it's going to be a stretch. So I'm going to say stretch vertically. All right, it's bigger than 1, that's why it's a stretch, and it's the y value, that's why it's vertically. Now, obviously, the scale factor is 4. So now I can go ahead and use that rule to find the images. So we're just multiplying all the y values by 4. So the x values will stay the same. All right, kept all the x values the same. Now multiplying by 4, I'm going to get 8 and 4 and -8. So now I just plot these points. -4, 8 is going to be right here. 2, 4 is going to be here. And -2, -8 is going to be right here. Let's connect those. So label this A prime and B prime and C prime, and we're done. So we can see that this was stretched vertically, and it is 4 times as tall as it was before. All right, look at problem number 3. This time we're given a graph and we're given some points, all right? The kind of like a before and after, the pre-image and the image. So at a glance, it seems like multiple things are changing. It seems like not only is it getting taller, but it's also getting wider. So this looks like a full dilation. So it's just a matter of what the scale factor is going to be. But a dilation is when it's changing horizontally and vertically at the same time. So let's see what happened. Look at these x values. From 3 became a 6. Clearly that was multiplied by 2. All right, let me change my ink for a quick second. The 4 became 8. Again, that is multiplying by 2. So that really tells us that the scale factor must be 2. Okay, they've already done the graph, so all we need to do is write the rule. So, like I said, it's changing horizontally and vertically. So that means we're going to multiply the x values by 2, and we're going to also multiply the y values by 2. And that's it, because the points in the graph were already done for us.